Hello and welcome to Unit 3 Equation Solving. We're going to get started on Lesson 1, which is one-step equation solving. And in this case, we have Pizzazz pages 28 through 33 that will help us kind of get some practice on the idea of one-step equation solving. And make sure you put your name and date on this situation here. So this note sheet is going to help us out. We're going to talk about some vocabulary, key concepts, and other items with some examples that are completely guided. Now, we have seen equation solving before in pre-algebra, and the idea here is to remind ourselves about what's happening, making sure that we incorporate some really positive, strong foundational skills, and we'll move on to some more advanced and challenging problems as we progress through this unit. So let's start off with our vocabulary of inverse operations. These are operations that undo each other. And that's the important piece that we're working with, is that inverse operations is how do I get rid of addition? Well, I can subtract something. And how do I get rid of multiplication? Well, I can divide something. So addition, the inverse is subtraction, and likewise subtraction, its inverse is addition. Now multiplication, its inverse is division, and division, its inverse is multiplication. So let's go ahead and take a look at some key concepts. So the method for solving one-step equations. It's important to first make sure that we classify the type of equation. If it's a one-step equation, then we can follow the method below. If it's not, then we're going to want to look through our other note sheets as we progress through and use the appropriate note sheet. The second step is to identify the original operation. This means that we want to really read the sentence. So what is the equation saying? Sometimes I read it out loud to myself. So consider reading the math sentence. The next step is number 3, and we want to simplify if possible. That means combining like terms or changing subtraction to addition and adding the opposite. Make sure that when we change subtraction to addition that we in fact add the opposite. That's a huge piece that we often forget. The next step when we talk about the method for solving one-step equations is to use the inverse operation to isolate the variable. And when we talk about isolating the variable, we're really talking about solving for x or y or z or whatever the variable may be. But we usually use x, so that's why I wrote solve for x. The next step is to check your solution, and this is our final step. We want to do this by rewriting the original equation. That's where we're going to start, is to rewrite that original equation to check the solution. The next step when we are checking is going to be substituting our solution that we found into that original equation. We're then going to want to simplify using order of operations. Now make sure that we are using order of operations instead of resolving the problem. A check is not a resolve, it is using order of operations after that substitution happens. So make sure that that's the way that you are checking your solution. Normally at the end I'll do a double check, and sometimes I'll even write out that this is my check as a label to what I'm working with. Let's go ahead and do some guided examples. So our first example that we're working with is x minus 15 equals negative 8. And the first thing that we want to do here is identify what's happening. This is a one-step equation, and I want to identify that the current operation is subtraction, so I want to add. I'm going to add 15 to both sides because that's the operation that is currently happening to x. So if I add 15 to both sides, I can cancel out the negative 15 and the positive 15, and I get x equal to 7. Now, x is a positive 7 here because the 15 is larger than the 8, and the 15 is positive, using those integer rules and skills. We're going to go ahead and do a check for this. So I'm going to rewrite the original equation of x minus 15 equals negative 8. Once I've rewritten the original equation, I'm going to go ahead and I'm going to substitute my value I think is x. I think x is 7. So where I see x, I'm going to input 7. So now I'm writing 7 minus 15 is equal to negative 8. So I've substituted. The next step is to solve using order of operations. So that tells me that I'm going to go from left to right, and I'm going to work with the 7 minus 15 to start. So 7 minus 15 is negative 8. It's the same thing as negative 8. Yes, that is true. So I can then go ahead and box in my x equals 7 on the left-hand side. This is my double check, in fact. So I often will write a double check if these are equal. It is a true statement. Be careful not to think that x is negative 8, that our check is just making sure that we have a true statement. Our example number 2 we're going to move on to is 23 plus h minus 9 equals 2. So we're going to want to simplify by combining like terms, and the 23 and the negative 9 can be put in together to give ourselves h plus 14 equals 2. Now when I take a look at this, I currently have h plus 14, so I'm adding. When I'm adding, my inverse operation is subtraction, so I'm going to end up wanting to subtract 14 from both sides. I can go ahead and cancel out what's happening to the variable, so the plus 14 and the minus 14 on that side. And again, we do it to both sides because we're balancing that equation. If you remember back from pre-algebra, we have to do what we do to one side, we have to do to the other. So we cancel those out and we get a h is equal to negative 12. We're going to go ahead and check that before we box it in. So our check is the original equation. Don't go back and plug it in for h plus 14 equals 2. We don't want to go that route. We want to go to the original. It will take a little extra work, but we'll make sure that we didn't make a mistake in our solving. So where I see h, I'm going to plug in a negative 12. And now I'm going to go ahead and use order of operations to solve. So I'm going left to right. And I can organize this as 11 minus 9 equals 2, and in fact 2 does equal 2. That is a true statement. So I can go ahead and box in my answer where h is equal to negative 12. We have a couple more examples for you. Let's go ahead and move to the back page of our note sheet. We're going to organize some new vocabulary as well. So we're going to start off with some vocabulary indicating what a balanced equation looks like. So when we talk about a balanced equation, that's when what you do to one side, you must, in fact, must do to the other side. And when I'm talking about one side versus the other, I'm talking about the side that is divided by the equal sign. So my equal sign is my division point, in which is going to tell me what is on one side of the equation and what is on the other. And since we're given that they're equal to each other, we have to make sure that we continue along with the balance. So if we multiply to the left, we need to multiply the same number to the right. All of those pieces. Let's go ahead also and remind ourselves about some key vocabulary pieces and ideas with fraction operations. So under this key concept here, we're going to go ahead and take a look. We have some adding and subtracting fractions. We're going to remind ourselves we need to have common denominators. And when we multiply fractions, we need to cross-cancel. Now, when we divide fraction, this is where we talked about keep, change, flip. So we're going to have the keep, the change, and then the flip. All right. So from here, we're going to go to our third example, and this one we are going to have to simplify before we move on. It says negative 72 is equal to 10x minus 2x. So here what we can do when we are simplifying is we can combine like terms with the 10x minus 2x and get 8x. So our answer, once we simplified, will be negative 72 equals 8x. Here we notice that what's happening between the variable and the coefficient is it's being multiplied. So the inverse of multiplication is in fact division. I'm going to want to divide both sides by 8. So when I divide both sides by 8, I'm going to get 1x. And a negative divided by a positive gives me a negative answer. So I'm going to get a negative 9 is equal to 1x. Now many people don't like to have the x on the right-hand side, so we can always flip-flop that. My suggestion is not to flip-flop that until the very answer. So I have x is equal to negative 9. We're going to go ahead and check this. I get negative 72 equals 10x minus 2x. This is our rewrite of our original equation. Now we're going to go ahead and substitute in negative 9 everywhere we see x. So I have negative 72 equals 10 times negative 9 minus 2 times negative 9. I'm going to simplify by saying negative 72 equals negative 90 minus negative 18. The minus negative gives me a plus plus, so I went ahead and plus plussed. And I'm going to simplify using order of operations. So negative 90 and positive 18 put together are going to give me a negative 72. This is my check because I wanted to make sure negative 72 equals negative 72. There's my true statement, and we're going to go ahead and box in our answer of x is equal to negative 9. Well done. We have one or two more to go. I believe we have 2 more problems. The next problem we're going to work with is one that has division as our current operation. So 4 minus 7 equals k over 12. And when we talk about that fraction bar, k over 12, that means division. Before we go ahead and do anything else, we're going to want to be sure and simplify. So I'm going to say we're going to simplify 4 minus 7. And if we wanted to show the add the opposite, we can absolutely do that. And we'll show this here by adding a negative 7. And that's where we get the negative 3 is equal to k over 12. Now again, the over means division, so in order to find the inverse of division, it's multiplication. I'm going to end up multiplying both sides by a positive 12. When I multiply both sides by a positive 12, where I had my variable, I can cancel out the divide by 12 and the multiply by 12. That will end up giving me 1k. And the 12 times negative 3 is giving me a negative 36. So 1k is the same thing as k. We don't have to write the 1, it's optional. So we're going to write k equals negative 36. Moving on to our check now. We're going to rewrite the original problem. And 4 minus 7 equals k over 12. And then substitute in negative 36 where we see the k. And I have that in red to help you out. So again, we're using an order of operations and we want to simplify both sides. So when we take a look at this, we should see that negative 3 equals negative 3. When I divide a negative by a positive, I do in fact get a negative answer. And when I add 4 and negative 7, I do get a negative 3. So it does check out, and we can go ahead and box in our answer, where k does in fact equal negative 36. Now our last example to go through is one with fractions. And I wanted to show you this as a preview for what's coming ahead, as this kind of starts to hint at where our fraction operations are going to come in handy. and as we make it a little bit more challenging and provide more challenge to those that are ready for it. So our first, and for this video, our last fraction example is 3 over 4, or 3/4 x, equals -1/8. So when we go ahead, we are currently finding that 3/4 x equals -1/8 is a situation where we have what's happening to x? Well, it's being multiplied by 3/4. So in order to undo that multiplication of 3/4, I want to divide by 3/4. And when we go back to our previous situation, when we were talking about our operations, and I'm going to pause here and go back so we can review those operations. Under our key concepts right here, when we divide fractions, it's where we keep the first one, we change it to multiplication, and we flip the second. So when I take a look at this then, I'm going to want to multiply by the reciprocal on both sides. So let's go ahead and do that now. So to multiply the reciprocal on both sides, I'm going to multiply the reciprocal of 4 over 3. Now that's really nice for us because I don't have to worry about this side over here. It's going to cancel out and I don't have to reorganize the 3/4 times the 4/3. That's okay. So I don't have to worry about the order of not placing the 4/3 as the second fraction, because now we're multiplying. And multiplication is commutative. I can move those numbers around. So when I take a look at this, I'm going to have some cancellation happen, because 4 times 3 over 3 times 4 is going to give me 12 over 12. And 12 over 12 reduces to 1x, so that's a really positive sign for us. We do in fact get x all alone, which is our isolation, in fact what we wanted. So when I do that, I get 1x. And I can also recognize that -1 times 4 and 8 times 3 can happen. Or perhaps I can notice that I have some cross-canceling I can do with the 4 and the 8. So let's notice that first. So there's 1 4 and 4 and 2 4s and 8. So when I multiply straight across now, I get -1 times 1 and 2 times 3, giving myself -1/6. So I can go ahead and write this as x equals -1/6, dropping the 1 in front of the x. And let's check this. So 3/4 x equals -1/8 is my original. Whoa, let's go back there. So with my original, I'm going to substitute in -1/6 for my x, which I show in red. And here I can also notice that in order to use order of operations, I can start to simplify this, and I can see that the 3 and the 6 can cancel. There's 1 3 and 3, and there's 2 3s in the 6. From here, now I can multiply straight across, so the 1 times -1, and the 4 times 2, and I'm going to hopefully get the idea of -1 over 8. In fact, I do, and so I've checked my original answer. That allows me to box in. This was obviously our first example with fractions. We're going to have more examples to come in our next video. See you in class. We'll make sure that we get this organized. Thank you so much for your time. Please come to class with questions as you see fit. See you later.